Hello friends, welcome back to my brand new channel HPS Tech, and in today's video we'll learn how to create an online dashboard for Govt using Java. So let's get started. So following are the tools that will be required for building our dashboard. First of all, our programming language, which will be Java 8, and then we'll be using Spring Boot and Spring Framework. As you know, Spring Boot provides a ready-made Apache Tomcat server to build web applications. Third will be IntelliJ, which will be our code editor. As per my reckoning, it is by far the best code editor for Java. Then we'll be using Maven as a build tool, and again, it helps us managing our all dependencies and building our code. And we'll be using JSoup, which is a Java-based library for web scraping. And we'll be using ThymeLeaf, which is basically a Spring-based scripting library. So I want to tell all my viewers that the code for this application is present in my GitHub library. You just need to go to github.com/sumitpalsingh007/Govt and you can check out the code for this application. Now let me walk you through the code of our application. As you can see, this code is imported in our IntelliJ IDE and it is a Maven project. You can see we have the pom.xml where we have all the dependencies, or you can say all the libraries which we use to build this application. You can see that we have Spring Framework, Spring Boot. We are using S2 database, which is an in-memory database. And as mentioned earlier, we are using JSoup, which is basically a Java-based web scraping library. And we are using ThymeLeaf, which is basically a Spring-based templating language. So these are the dependencies for ThymeLeaf. And this is basically a testing dependency for writing integration tests using Spring Boot Starter Test library. So basically this is the pom.xml, and whenever we build our code, it will check whether all these libraries are present in our local Maven repository or not. If it is not present, it will download those libraries from the central Maven repository and keep a copy of them in our local Maven repository for further use. And you can see that the version of Java is specified as 8. So that's all about our pom.xml and all the dependencies and libraries which we are managing using our pom.xml. As we have seen, all the dependencies are well managed in the pom.xml. Now let me walk you through the controller package. As you can see, there are 4 controllers in this package. So the first controller is the home controller. It is handling the request for /home URL with the get mapping. So whenever the request for /home comes to our application, it will be received by this controller, and in this controller we are checking whether the cookie is set in the request or not. So if the user would have been logged in, we would have set a login cookie in the application. So it will check whether if the cookie is present and the cookie value is true, it will return the user to the home page, and if the login cookie is not set, it will redirect the user to the login page. So now coming to the login controller. So whenever we receive the login request, it will be received by this method using a post protocol, and it will be taking arguments as a login form. So the login form is present here, and we can see that there are 2 attributes in this form, the username and password. So whenever we'll receive the login request, we'll get the login form, we'll get the model, and we'll also get the response. So what we'll do is we will check in the database whether the username and password pair which we have received is present in the database or not. If it is present, which means that the username and password are matching with the username and password saved in our database, we will create a cookie for the user, set a maximum age. In this case we have set it to 7 days, and then we will add this cookie to the response, and we will redirect the user to the home page, which means the user has been successfully logged in. And if the database doesn't contain the login username and password, in that case we will set the cookie as false, and then add the false cookie in our response, and we will redirect the user to the login page, which means that the user is not able to log in. So the user repository is injected in the login controller. This controller also contains a get method for the login URL, which means that first of all, when it gets a GET request for the login URL, it will return the login page. Once we receive the login page, it will contain the login form. Again, the user will enter the username and password, and when he clicks submit, then the second time the request will receive on the login post method. And then, as explained earlier, we will check for the valid username and password and set the cookie according to it. We are also providing the facility to register a customer in our web application. So whenever the user hits the /register URL, first it will be received by the GET method. It will return the register page to the user. And second time, when user fills the registration form, so if I show you the registration form, it contains username, password, and a confirm password to match with the original password. So just 3 attributes here in our registration form. So when the second time the request is received by the register URL using the post protocol, it will contain the registration form, the model. So in this case, what we'll do, first of all, we'll check whether the password and confirm password are matching or not. If they are matching, we will save that user with the username and confirm password in our database, and then we will return the user to the login form. If the passwords are not matching, which means that there is some difference in the confirm password and password, we will return the user to the register page. So that's it. That's all in our registration controller. It also has the user repository injected into it. So the fourth controller is the state-wise controller. It contains the reference to our entity service. So whenever the request for state-wise data is received, it is received by this method. What we do is we check whether the login cookie is present and its value is set to true or not, which means the user is logged in or not. If the user is logged in, we simply set an attribute in our model. The attribute name is the state-wise data, and the attribute's value is the complete dashboard data which we fetch using our entity service. And then we redirect our user to the home page. And if the user is not logged in, we again redirect the user to the login page. So the second package is our entity package. So entities are basically a replica of our database tables. So the first entity which I'm showing you is the stats entity. You can see with the annotation that it is a replica of the state-wise corona stat table from our database. And all the properties in this entity, for example, ID is the replica of the capital ID property column in our database. Name is the replica of the name column. Active cases count is the replica of the active cases count in our database. Similarly, resolved cases count, death cases count, and total cases count, all these are replica of the columns. All these are replica of the corresponding columns in the database. Similarly, we have our user entity. Again, it is a replica of the user table in our database. So it contains ID, username, and password. And the ID here is getting automatically generated every time we insert a new user in the database using the generated value and annotation. And yeah, so pretty simple, just 3 properties in this entity. So these were our entities. So since we are using Spring Framework, Spring provides us with a module called Spring Data, which is basically responsible for interacting with database using ORM, which is object relational mapping, which means mapping the database columns with the Java classes. And the underlying framework which it uses is Hibernate, and it serves as a mediator between Hibernate and the developer writing the code. So the next package is our repository package. It contains 2 repositories, the stat repository and the user repository. So in this repository packages, you can see that we don't have any classes. We just have interfaces annotated with the @repository annotation, and which are extending the JPA repository parent interface. In the generics of the extends, we specify that this repository is for which entity. So in this case, it is for the stat entity, which we have shown you earlier. And what is the type of its primary key? And since it's long, we have used long. And then we just specify queries and map them with some methods. So as you can see, @query annotation, and here we are simply selecting all the data for which we have saved in our database for the corona stats, and we are mapping it with the state, each row with the state entity and returning it. So that is why the return type of this method is list, and they are pretty straightforward that it contains only one method. And similarly, there is user repository. Again, in the generics we have specified that it is the user entity repository, and the primary type of the user is long, so we have used long. And again, it also contains just one query, where simply we are passing the username and password and checking whether the user exists or not. If the user exists, just return its primary key as an identifier that there is one entry present in the database. So we are using this method to identify whether the username and password pair which has been provided is existing in the database or not. So that's all in the repository package. So the next package in our application is a scheduler package, and it contains one class which is a scheduler class. So it is simply annotated with a component annotation, and it has two classes injected in it. The first one is the scraper class, and second one is the entity service class. So both these classes are auto-wired into this class using the constructor auto-wiring. And as you can see, it contains a schedule scraping method with the scheduled annotation, which means that this method will get called by the Spring framework itself after every 100,000 seconds. 100,000 is a constant here, and we have defined its value as 100,000 here. Okay, so whenever this class gets called by the Spring framework via the scheduled annotation, what it does is that it calls our scraper class and gets the co-void data, and then if there is no exception, it persists the co-void data using the entity service. So basically, it is kind of for a mediator between our scraper and our entity. So it's asking the scraper to scrape the data from the government website. Once the data is received, it is asking the entity service to persist the data in the database. And as an additional functionality, we have used a post construct annotation to add an admin ID and admin password user into the database, which means even if we don't have any registered user, at least we are having one admin user whose ID is admin and whose password is also admin. That's all in the scheduler class. Now we come to the scraper package, which is the most important package of this application. It contains a scraper class, and as you can see, it is annotated with the component annotation. So for the purpose of scraping data, we are using JSoup, and we are asking JSoup to connect to Ministry of Family Welfare website. As you can see, this is the URL, and I've opened the website here, and on this website there is a table for state-wise stats of corona. So it gives you the name of the states, active cases, cured, discharge cases, deaths, and total confirmed cases. It has data for all the states available here, and in order to read this table, we'll have to tell JSoup where this table lies on this web page. So what we'll do, I right click and open the developer panel, and I'll use the inspect element tool available here. Once I click on the heading of the table, I can nearby find a section which is called state data. So this state data section I have configured in my JSoup code. So first of all, I'm asking JSoup to connect to this web page. After connecting, we are asking JSoup to get the element by this ID, which is a state data here. You can see state data here, and we have configured the same state data in our code. And then once it is able to find state data, we are asking it to find a table under this section state data. So as you can see again, if we go inside state data, there is a table available. This is the table, and these are the rows which are individual state entries here. So we'll basically ask JSoup to iterate over the rows of this table and fetch the data. So TR stands for rows and TD stands for columns inside the rows. So all these states, for example, Andaman, Nicobar, Andhra Pradesh, all these are rows, and all these data inside the Each row, example, the name of the state, active cases, discharge cases, deaths, etc., are the columns in the table. So these are represented by the individual TDs. This is a basic simple HTML concept, TR and TD for a table. So we are asking JSoup to iterate over this table and fetch the TR and TDs. So some of the columns in this table we don't want. For example, we don't want the heading, and there are a few text messages at the bottom of this table that we don't want. So we have placed the if condition in our code to identify whether we want the data or not. So this method is row required or not. In this is no not required method, we are basically just checking the data of those columns and ignoring the iteration for those columns. So once we have checked whether we want the particular row or not, so basically we are just ignoring the below text rows and the topmost heading row. Rest of the data we want. So once we have checked, and if the row is really required, we get into the iteration, and then we first check whether data is present. If it is present, we initialize our state stat entity with we set its name for the name of the state, then the active count, the resolved count, the deaths count, and the total count. So these are individual TDs in each TR row. So you are first checking with the iterator whether iterator has next. If it has next, then simply set this value. And then we are maintaining a list of all these stats entity. We are adding that entity to the list, and finally we are returning this list from our methods. So basically JSoup offers all this scraping functionality ready-made. You just need to call it some methods, and you can just give the ID of the table or the section where you want it to scrape your data, and it is able to scrape your data quite conveniently. Just make sure to check whether the data is present or not before you try to persist it. It's a good practice to follow. So this is the most important logic in our code, where we are using JSoup to read the government web page and read the stats. And since it is on the behind, it is getting called from a scheduler class, so it is running at a fixed frequency which I have figured as 100,000 seconds, and it's continuously scraping the data from the web page at this frequency. So that's it in our scraper package. For more information about JSoup and how JSoup works, you can visit the official website of JSoup, which is jsoup.org, and here they provide you samples and documentation of their API and downloads as well. So you can just go through and see the various features of this JSoup API. And coming to the last package of our application, which is the services package. It contains an interface entity service. As you can see, this is our interface. It contains two methods. First one is persist corona data. It takes a list of state stats and persists it. And second one is get the corona stats. It fetches the list of state stats from database and returns. And we also have the implementation of this interface. We have injected entity manager, which is the basically Hibernate's API for connecting to database, fetching data, retrieving data, and updating data. And we also have the state repository interface, which we have discussed earlier, for doing transaction related to state. So basically, in case when we are receiving a list of state stats to be saved in database, which is the persist corona data method, we have marked it as transactional because we are updating data in the database. So whenever we are updating data, we mark that method as a transactional, so that to maintain the atomicity and so that there is no data corruption and the correct data gets updated in database. So basically we are calling for each on the list, and for each entity of this data list, we are calling entity manager.merge. This is basically persisting data in the database, and if that data exists or if that row exists, for in our case the scraper is running multiple times, so there is a high chance that entry for that state is already present. If it is already present, we just update the values, simply update the values. So that is why we are calling merge instead of persist. And the other method is get state-wise corona data. It is simply using the state repository and fetching all the state data. Here we don't need any transactional because we are not updating anything in the database. So this is basically our entity service impl, and it is basically using the entity manager and repositories to fetch data from the database. Now we move to the resources section of our application. So as you can see in resources, we have the application.properties file, which is the basic Spring configuration file, and we have some templates. So let me walk you through the templates first. So first is the home page, home template. It basically contains the code for your home page. Then when you are logged in, you'll see the table. You'll see a link. A stands for anchor tag. So basically, it will hit this URL and fetch the table data. And then we have the table, all the headings, and then we are receiving a list of state stats. So we'll for th each is basically like an iteration over the list. So after iterating on the state-wise data, we are for each particular entry is represented with this variable stat. So we are populating the values for stat, ID, name, all these things, total cases, active cases, deceased cases, all the data from our list objects using this for loop. And this th namespace is the Thyme leaf namespace, and it provides us some custom methods like each and other things. So basically this is our home template, which contains our table. Then we have the simplest template, which is the index template. Whenever anyone hits the URL of our application, it will land to the index.html. This is a basic web application concept. So whenever anyone lands on the index.html, it will show them a welcome message, welcome to Govt tracker, and we will give them two links. One is the login link and other is the register link. So in these two links, we are having the get mapping for these two methods. And when the user hits these links, they will get redirected to these pages. And then let me walk you through these pages. So in the login page, you can see we simply have a login form. We have a form, we have the username, password, and a submit button. So whenever user hits the login button, and in this case, this /login is different from this /login. This /login corresponds to a get entry, and which takes you to this login page. Whereas this /login corresponds to a post entry, and it wraps your data in this login form DTO and passes it to on the server for validation. So it takes the username and password and wraps the values in this DTO and passes it to the controller for validation. Similarly, there is a register page on which we have the register form. So it has /register post call. It will wrap whatever data you are filling. In this case, is the username, password, confirm password. It will wrap these value in the register form DTO, which are here. You can see login form DTO. You can see the register form DTO. So it will wrap its data in the register form DTO, and when you hit submit, it will send this data to the controller for registration. So these are our templates for for maintaining the view of this application. And then we have the application.properties, which is the standard file for Spring Boot application, where you maintain the Spring Boot configuration. As you can see, we are using S2 in-memory database, and that is why we have enabled S2 as true, and we have given the URL of S2 database, which is in-memory. Since it's in-memory, we have mentioned MEM memory, and we have given the name to the database as local DB. And we have just kept a username, no password required. We have specified to use the S2 driver to connect to the database, and we have specified Spring JPA to use the S2 dialect. And there are some other logging configurations as well in this file. Since we have gone through all the packages and resources of this application, now let me demonstrate to you the working of this application. So to launch this application, I'll simply run the launcher class as a main method. And when I run the launcher class as a main method, it will start the Spring Boot web server for us. As you can see, it is printing the Spring message here, and it is initializing our Spring Boot Apache Tomcat web server. So we are getting some startup logs here, and within a couple of seconds we will be able to see that our server is initialized. So, you can see the starting message for our database, and then it is reading all the controller mappings which we specified in our code, and finally it is giving us the startup message that it took 36 seconds to launch your web application. So now just let me show you our application. So I'll simply go to the browser and type localhost 8080, and what localhost 8080 will do, it will go and read the index.html file in our resources. As you know, index.html is the default file for web applications. So when it reads the index.html file, you can see the welcome message which we have written there, and we show you that we mentioned two links there, one for login and one for register. So I'll simply click on login, and as you had seen that we created a default user with admin username and admin password. So I'll simply use those credentials to log into the application, and once I log into the application, I reach the home page. The URL is showing login because it is a post request to redirect to the home page. So basically we are at the home page. If you want, if I type home as well, I will still be at the same page. So any which way, since we are at the home page, when I click on show table, it will show me the freshly scraped data from the government web page. And we have configured a fixed frequency at which our scheduler runs, and then it scrapes the fresh data from the government web page. So this is pretty much the live data which the government is publishing right now. And the authentication of this application is a cookie based authentication, as we showed you in our controller that we were creating a cookie, then we were setting its maximum time, and then we are setting its value as true and false. I'll show you that cookie gets created here. So since we are logged in, that is why this login cookie has a value true, and the number of times you refresh or do anything with this application, you will be logged in. If I delete this cookie, then our session will get destroyed, and then if I try to refresh this application, it will return me back to the login page. Why? Because in our controller we had mentioned whether if the login cookie is present and its value is true, then only let the user be present at the home page, otherwise redirect to the login page. And that is why it is redirecting us to the login page. And if I go back to our index.html file, which is if I just remove this URL and I'm at my index.html file and I try to register a new user, for example, I give SPS as a username and I give it a password, and you can see that in this case I'm redirected to the login page. And now I try to test my credentials, the ones that I entered, and you can see that I'm able to log in again. And I'm again at the home page, and it is showing me the show table link, and once I click it, I get the freshly scraped data from the government website. So this is how our application is working. And if I try to give you a dry walkthrough of how the request flows, so whenever you type the hostname of the web application, you will reach at this index.html page. It contains two links for login and register. Once you click on this login page, it will go to the login controller and to the get part of this login controller, and then it will return you the login page in return. And when it returns you the login page, basically this page opens on the browser. When this page opens on the browser, you get a login form with the username and password. When in this case you enter username and password, it again hits the login URL, but this time with the post method. So it goes back again in the login controller, with the login URL, but the post method, here it checks whether your username and password are present in database or not. If yes, it creates a cookie and it sets in your response and returns back to you. And also it redirects you to the home page. When you go to the home page, you get the link to view the dashboard, and since your cookie is present, it again goes to the home controller. It checks whether the cookie is present. If it is present, it allows you to remain on the home page. Otherwise, it redirects you to the login page. And this way, a cookie-based authentication mechanism works for our application. So I'll also like to state to our viewers that if you want to deploy this application on AWS, we have a video created for this, how to deploy a web application on AWS. You see the link for that video on the top of the screen, and you can watch this video for learning how to deploy a simple web application on AWS. So this is all about our web application and its functioning. So friends, I hope that you must have liked the demonstration of a Govt application using Java, and you would have understood the functionalities which we have written in our application. Do check out this application link from GitHub and then go through the application code. And if you feel any doubts, feel free to post in the comment section, and I'll be more than happy to reply to your comments. And I hope you must have liked this video and the explanation. And I request all the viewers, those who have not subscribed to our channel, to please subscribe to our channel. It gives us the right motivation to create more interesting videos for you. So do hit the like button on this video and subscribe to our channel for further updates, and keep watching our videos, and stay at home, stay safe, take care of your family, your health. And till then, this is SPS signing off. Take care. Goodbye.